Steel isn't just turned into a tank by accident. It's designed, it's tested, it's shaped, and it is hardened for one single purpose: to dominate the battlefield. Modern tanks are far more than just vehicles. They are mobile fortresses, engineered to absorb punishment, return fire, and keep moving forward no matter what. This is the story of how a tank is built. Every tank starts its life not as a blueprint, but as an idea. Military engineers and designers gather in rooms filled with advanced computer simulations, not drafting tables. They debate one critical question above all others: what will this tank face in a future war? They consider enemy tanks, anti-tank missiles, improvised explosive devices, and the ever-present threat of drones. Every potential threat shapes the final design. It's a constant balancing act. Weight must be traded for speed. Armor thickness is balanced against mobility. Firepower has to be weighed against reliability and ease of maintenance. Modern tanks are designed entirely in the digital world. They face virtual explosions and simulated battle damage long before a single plate of steel is ever cut. Let's talk about the skin of this beast: its armor. Tank armor is not just a thick slab of metal. It's a highly classified, multi-layered, and brilliantly engineered system. Most modern tanks use what's called composite armor. This is a sandwich of different materials like high-hardness steel, advanced ceramics, and other secret polymers, all designed to shatter, absorb, or deflect incoming projectiles. To counter guided missiles, many tanks are fitted with explosive reactive armor. These are small blocks on the exterior that detonate outward when struck, destroying the incoming warhead before it can even touch the main hull. Every single plate of this armor is precision cut with lasers or water jets, heat-treated to achieve the perfect hardness, and then welded together with incredible accuracy. A single mistake, a single flawed weld, could cost lives in combat. With the armor prepared, it's time to build the hull. The hull is the tank's backbone, its very foundation. Skilled workers weld these massive, heavy armor plates together, meticulously forming the main structure. This structure creates the crew compartment, the engine bay, and the secure ammunition storage areas. The underside, the belly of the tank, is heavily reinforced to withstand blasts from mines and roadside bombs. Even at this early stage, with no engine, no turret, no tracks, the hull alone can weigh tens of tons. It's a static, unmoving mountain of steel, waiting for its other vital components. Now for the part that delivers the punch: the turret. The turret is a complex fortress in its own right, and it's built completely separately from the hull. Inside this rotating structure sits the heart of the tank's offensive power. You have the main cannon, the sophisticated fire control computers, and the gyroscopic stabilization systems that allow it to fire accurately while moving. The gun barrel itself is a masterpiece of metallurgy. Forged from a single piece of high-grade steel, it's machined to microscopic tolerances, and often lined with chrome to withstand the extreme heat and immense pressure of firing. When the turret is fully assembled and equipped, it can weigh more than a city bus all by itself. So, what moves this 70-ton monster? It's not about winning a drag race, it's about pure, unstoppable torque. A tank engine is an absolute powerhouse. Most modern tanks use diesel or gas turbine engines that produce between 1,200 and 1,500 horsepower. This incredible power is what allows a 70-ton machine to push through mud, claw its way over sand dunes, and smash through rubble. The engine and the transmission are assembled together into a single, compact unit known as a power pack. This brilliant design allows a damaged engine to be swapped out in the field in a matter of hours, getting the tank back into the fight as quickly as possible. Of course, an engine is useless without a way to put that power to the ground. Wheels simply wouldn't survive on a battlefield. That's why tanks move on tracks. Each individual track link is a marvel of engineering, assembled one by one. They're designed to grip soft ground like mud or sand, absorb the shock of rough terrain, and withstand incredible damage. But what keeps the tank from bouncing all over the place? That's the job of the suspension system. Whether using tough torsion bars or advanced hydropneumatic units, the suspension keeps the tank remarkably stable. This stability is the secret to a tank's ability to fire with pinpoint accuracy, even while moving at high speed across a bumpy field. In the modern era, a tank's brain is just as important as its armor. Today's tanks see the enemy long before they shoot. The crew compartment is packed with advanced technology. We're talking about thermal imaging systems that can see heat signatures through complete darkness, smoke, and fog. Laser rangefinders calculate the exact distance to a target in an instant. Digital battle computers process all this data, providing the gunner with a perfect firing solution. And encrypted communication systems link the tank to a wider network of friendly forces, allowing for coordinated attacks. This isn't about brute force anymore. This is digital warfare on tracks. Finally, the moment of creation arrives. Final assembly. All the separate pieces are brought together. In a carefully orchestrated process, a massive crane slowly lowers the fully equipped turret onto the hull. The satisfying click as it locks into place signifies a major milestone. Teams of technicians then swarm the vehicle, connecting thousands of wires and electronic systems. The ammunition is carefully loaded into its protected storage racks. Fuel fills the tanks. For the very first time, this collection of metal and wires starts to look and feel like a living machine, but it's not ready for war just yet. Before any tank is delivered to the military, it is tested to the point of failure. It undergoes grueling live-fire tests on the gunnery range, proving its accuracy and reliability. It's pushed through brutal off-road trials tackling impossible slopes and deep water. It's subjected to extreme heat and freezing cold in climate-controlled chambers. Its electronics are blasted with electromagnetic pulses to simulate electronic warfare. If anything breaks, it's sent back to the engineers to be redesigned and strengthened. Failure is not just allowed here. It's expected. Because failure in testing is infinitely better than failure in combat. After months of construction and weeks of relentless testing, the tank is finally ready. It receives its final coat of camouflage paint, is sealed against the elements, and is officially delivered. From raw steel to a state-of-the-art weapon of war, the journey is long, costs millions of dollars, and demands absolute precision from thousands of people. What emerges from the factory is not just a machine. It's the physical embodiment of engineering prowess, battlefield experience, and hard-won lessons from decades of conflict. A tank is not invincible, but every single bolt, every weld, every computer system, and every piece of armor exists for one primary reason: to give its crew the best possible chance to survive and win. And that is how a modern tank is built. Thanks for watching, and if you found this interesting, don't forget to like and subscribe for more deep dives into the world of technology and engineering. See you next time.